Welcome to the Explainer. Today we're exploring a true crucible of systems administration, the offline production upgrade. We're not just talking about a minor bump here. We are unpacking a massive leap for a GitLab server, taking it all the way from version 13 to 17.6. And because this scenario focuses on a production environment running completely offline, well, the stakes are incredibly high. There is absolutely zero tolerance for data loss, and minimizing downtime is absolutely critical. We're going to break down exactly how this is accomplished, the terrifying errors that inevitably pop up along the way, and the precise solutions that bring the system safely to the finish line.
Okay, let's dive into this. Here is our mission roadmap, so you know exactly how we will conquer this complex process step by step. First, prepping the offline environment. Second, navigating mandatory upgrade paths. Third, executing the upgrade sequence. Fourth, overcoming unexpected hurdles. And finally, final validation and lessons.
If you manage IT infrastructure, that question probably triggers a bit of technical dread, right? You look at the official documentation, and instead of a simple direct update, you're met with this complex maze of upgrade paths, hard stops, and the looming threat of unexpected system errors just completely breaking your workflow. Upgrading enterprise software in these conditions is a total high-wire act. And that core problem, the anxiety and complexity of a major version jump, is exactly what we are unpacking in this explainer today.
And this brilliantly illustrates the strict parameters of our environment, reminding us that production means zero tolerance for downtime. We're looking at Red Hat Enterprise Linux 7.9, running GitLab Community Edition, with a massive upgrade path from the 13.x series all the way to 17.6. And the kicker? The status is offline production. A production server means real users, real data, and real consequences if things go wrong. Add the fact that it's totally air-gapped, meaning no quick internet searches to automatically pull down missing dependencies on the fly, and this becomes a scenario requiring absolute precision.
Section 1. Prepping the offline environment. Because the golden rule of production is meticulous preparation.
The very first rule of any production upgrade is incredibly simple, but skipping this step is a fatal mistake. Never start without a backup. Seriously, before changing a single line of code, you absolutely have to run these essential pre-flight commands. You verify the server's overall health with gitlab rake gitlab check. Then you confirm the current config using gitlab rake gitlab env info. It sounds basic, but you also have to check available disk space, because these extensive backups and new software packages will eat up storage remarkably fast. Finally, you execute gitlab backup create. Once that backup is securely locked away, the true upgrade process can actually begin.
Section 2. Navigating mandatory upgrade paths. Let's move to the biggest trap systems administrators fall into, assuming you can jump straight to the newest version.
So the crucial point is that GitLab simply doesn't allow a direct jump from version 13 straight to 17.6. You literally can't do it. The journey requires mandatory stops at specific required versions. As you can see, the path involves an initial stop at 13.12, then moving into the 14 series, the 15 series, the 16 series, and finally hitting that target of 17.6. Mapping out these specific chronological version stops is completely non-negotiable. Why? Because each stop ensures that complex background database migrations have the necessary time and the precise software environment required to complete safely, thereby protecting your data integrity throughout the entire day.
Section 3. Executing the upgrade sequence. Let's introduce the repetitive, but totally necessary, operational loop utilized at every single version stop.
At every single mandatory stop along that timeline, you're executing this critical four-step cycle. First, install the new package using your package manager, like yum install gitlab-ce. Second, tell the system to apply all those internal changes by running gitlab-ctl reconfigure. Third, bring the system back to life with a clean slate using gitlab-ctl restart. And fourth, which is absolutely vital, verify functionality before even attempting to advance to the next version. Mastering this specific operational rhythm is the absolute key to safely advancing through the upgrade path without leaving a broken infrastructure behind you.
Section 4. Overcoming unexpected hurdles. Let's slow the pace down for a second to dissect the real-world monsters you might encounter on this mission and look at some actionable troubleshooting tactics.
To understand our first major hurdle, we need to clarify exactly what background migrations actually are. These are essential database restructuring tasks. They run asynchronously, meaning they happen quietly in the background while the system appears to be otherwise fully functioning. But crucially, these invisible processes must finish completely before GitLab will permit the installation of the next version. If an admin doesn't realize these are still churning away, they become the absolute #1 cause of halted upgrades.
Now, what's really interesting about this slide is the exact command used to unblock the upgrade. When migrations are churning away in the background, your upgrade gets blocked. The system stubbornly refuses to continue. But by running the command gitlab-rake db.migrate.status, you pull back the curtain. This command shows the hidden progress and confirms exactly when task completion reaches 100%. Once you see that, you're unblocked and can safely proceed to the next mandatory version stop.
But background migrations aren't your only headache. In an offline environment, package dependencies become a massive roadblock. If an installation halts because it needs a supporting package, you can't just fetch it over the internet. It requires handling manual RPM management completely offline. Then there's PostgreSQL. The system relies heavily on it, and certain upgrades mandate intermediate database migration specifically for PostgreSQL before the main software upgrade can continue. Finally, the highly restrictive nature of offline repositories demands grueling preparation. Literally every single package and dependency has to be downloaded and moved to the server strictly in advance of your actual maintenance window.
Looming over all of these tasks is the operating system itself. A critical reality check you'll encounter here is the RHEL 7 limitation warning. As GitLab versions get newer, their support for older operating systems becomes increasingly limited and eventually drops off entirely. This means the life cycle of your underlying OS, like Red Hat 7.9, directly dictates your upgrade viability. Extensive ahead-of-time planning regarding the operating system isn't just recommended, it is strictly required to keep your overall software stack up to date.
Section 5. Final validation and lessons. Time to transition to the final victory lap of the explainer and prove this methodology actually works. Hitting version 17.6 is a major milestone, but the job isn't done until the system is fully validated. I can tell you, there is an intense feeling of relief when you run these final checks. It starts with verifying overall health one last time with GitLab rake gitlab-check. Then, you manually confirm that the login page and web interface actually load properly for your end users. You've got to dive in and check that all historical projects and code repositories remain completely intact. And finally, for a modern DevOps environment, it's absolutely critical to ensure that all CI/CD runners and pipelines are fully operational and picking up jobs. Confirming full functionality across the entire platform is the ultimate payoff. Let's move to and see how this builds into the 5 ultimate lessons distilled from this real-world survival story. 1. Never skip required upgrade versions, no matter how tedious those intermediate steps seem. 2. Always create full backups before changing a single configuration. 3. Aggressively monitor those asynchronous background migrations to prevent blocked installations. 4. Verify system health at every single intermediate step, not just at the very end of the process. And 5. Whenever humanly possible, test this entire sequence in an identical staging environment first. So as we wrap up this explainer, I want you to think about your own environments. Is your offline infrastructure fully backed up? Are you truly ready for the complex jump to version 17.6? Upgrading enterprise systems offline is a massive challenge for sure. But as the documentation and these operational steps show, with strict preparation, immense patience, and an understanding of the exact commands needed, it is entirely achievable. I really hope unpacking this process helps clarify the demands of your next major upgrade. Keep exploring, keep testing, and I'll see you in the next explainer.